The least common multiple of two numbers is the smallest number that you can have that's a multiple of both numbers. And we need least common multiples for a lot of different things throughout our algebra course. Probably most notably is when you're adding fractions. This is how you get the same denominator or a common denominator when you're trying to add two fractions together. Now there's a couple of different ways you can find the LCM of two numbers. One way is a little bit more informal, one way is a little bit more formal. The vast majority of the time, the informal way will work just fine. But in this video, we're going to cover both. I'm going to show you both ways of finding the least common multiple. The easiest way, in my opinion, and the more informal way, is to start with the larger of the two numbers and then write out just a few multiples of the larger number. So we'll write like 10, 20, 30, 40, 50, etc. And just to state the obvious here, it's very clear to us that all of these are multiples of 10 because that's how I wrote them. I wrote them as multiples of 10. So any of these would be valid multiples of 10. So now all I have to do is scan the list starting with the smallest numbers, looking for any one, just the first one in fact, that's also a multiple of 8. In this case, 10 is not a multiple of 8, neither is 20, 30 is not a multiple of 8, but 40 is. 40 is 8 times 5. And so as soon as you get to your first number, that's the LCM. This is a very easy way to find least common multiples. For the vast majority of examples you'll work, this way works well. It's quick, it's easy. Now, it's not always applicable though, because whenever you get especially very large numbers, this way can be actually more time consuming instead of less. So let's work one more example like this, and then I'll show you the other technique. So let's say we want the LCM of 6 and 20, and we're going to take multiples of the largest number, in this case 20. So we'll write out a few multiples of 20. We'll have 20, we'll have 40, we'll have 60, we'll have 80, and we'll do more if we need to after that. And then all of these are multiples of 20. Now, which one of these is a multiple of 6? 20 is not a multiple of 6. 40 is not a multiple of 6. But 60 is. 60 is a multiple of 6. So 60 is both a multiple of 6 and 20. I found it. So in this example, the LCM would be 60 of these two numbers. All right, now the other method is a little bit more involved, but sometimes it's necessary. So let me see if I can explain this technique to you. What we do is, if you have two numbers, the first thing you do is you find a prime factorization of each number. You take each number and you factor it down all the way until you can't factor it anymore. Then you're going to look for any common factors that might be in both of the factor sets. And we're going to make a product of all these common factors. All right, and then additionally, on top of that product, or increasing that product, we're going to multiply any remaining factors that are not common to the two different factor sets. I know this is a little complicated, so we're going to do a couple examples of this. Let me show you a few examples. 32 and 36. Those are so big, I don't think we'd want to take multiples of 36 and 36 and 36. That would take quite a while and the numbers would get very big. So here's what we're going to do. We'll take 32, and we'll take 36, and we're going to factor it completely. Let's start with 32. 32 is 2 times 16. 2 times 16. But 16 is composite. It's not prime yet, so let's factor 16. 16 is 2 times 8. But 8 is 2 times 4, and 4 is 2 times 2. So this is the prime factorization of 32. Let's do the same thing for 36. 36 is 2 times 18, but 18 is 2 times 9, but 9 is 3 times 3. All right, so this is the prime factorization of each number. All right, now let's make the least common multiple of these two numbers. So first thing, we're going to look for any common factors, and I've got 2's, and that's it. That's the only thing common. So we'll have a product of 2 and 2. Okay, I don't put 4 2's, I just put 1 2 for this pair and 1 2 for this pair. And then notice in green, I've got these other guys left over. that are not common to each other. So I'm going to tack on those as well. 2 times 2 times 2 times 3 times 3. But make sure you see where these are coming from. That product is the LCM, and yes, it's very big, but it is what it is. So we'll have, let's see, 3 times 3 is 9. We might have to make a little list here. 9. 9 times 2 is 18. 18 times 2 is 36. 36 times 2 is 72. 72 times 2 is 144. 144 times 2 is 288. So the LCM of these two numbers is 288. 288 is a multiple of 32, and it's a multiple of 36, and there's no number smaller than 288 that's both a multiple of 32 and 36. All right, let's see if we can do this again. 105 and 65. These are big numbers. Let's see if we can do the same thing. We have 105, we have 65. Break down 105. 105 is 5 times 21, but 21 is 3 times 7. So this is the prime factorization of 105. How about 65? 65 is 5 times 13, and 13's prime. So here we go. This is it. This is the prime factorization of each. So let's make a least common multiple of these two numbers. I've got a common factor of 5, and so I'll put a 5 in my least common multiple. And then I've got a 3, a 7, and a 13 that are not common to each other. So we'll tack those on as well. We'll have a 3 times a 7 times a 13. We'll simply multiply all these guys, and then that'll be our final answer. Just to save a little time, I went ahead and plugged these into the calculator already, and I got 1,365. So 1,365 is both a multiple of 105 and 65, and there's not a smaller number than 1,365 that's a multiple of both of these numbers. So anyways, hopefully these two techniques will serve you in any given situation, and hopefully you better understand how to find least common multiples of two numbers.